Now let's take divisibility rule of 11. It says that starting from the unit digit of the number, we have to find the sum of the digits, sum of the numbers digit at even place and odd place separately. And then we have to find the difference of these two sums. We should always follow this order, that odd place digit sum minus even place digit sum, because you will have an advantage that if you want to find the remainder, then the difference itself will be the remainder. If the order is that the odd place sum is taken first and it is the even place digit is subtracted from the odd place digit. So now if the difference, once we found the difference, and if the difference is divisible by 0 or a multiple of 11, then we can say that the number is divisible by 11. So let's apply the rule to solve these examples, and later on, and I also give you the logic that how this rule works. So let's solve the example first so that we understand what this statement says. So this is the number and we have to find whether this number is divisible by 11 or not. So we have to start from the unit digit. So let me write these numbers here. So the number are 6, 5, 9, 7, 0, 3, 2, 1 and 0. So you have to always start from the unit digit. Although you can start from this place also, but therein we will not be able to get the remainder correctly. So the first thing is that we have to find the odd place digit sums. So this 0 is at odd place. This is the first place. 2 is at the third place. Then 0 is at the fifth place. Then 9 is at the 7th place, and then 6 is at the 9th place. So we have to find the odd sum. So let me call it odd sum. So this will be 6 plus 9 plus 0 plus 2 plus 0, and that sum comes out to be 17. Later we have to find the even sum, that is the digit at the even place. So it will be 1 plus 3 plus 7 plus 5, or 5 plus 7 plus 3 plus 1, which comes out to be 16. Now we have to maintain this particular order. So the difference will be 17 minus 16, which is 1. Since 1 is not a multiple of 11, hence this number is not divisible by 11. At the same time, we can also say that when this number is divided by 11, then the remainder is the difference if the order is maintained. That is what this note says, that if the difference obtained is also the remainder when divided by 11, provided we keep the order same. And at times, what happens is that you get a negative remainder also. For example, suppose the odd sum of some of the number is say 15, and the even sum of some of the number is say 20, then the difference you get here is minus 5. Although minus 5 is not a multiple of 11, hence the number n will not be a multiple of 11, but the remainder, but to get the remainder, we have to change from negative remainder to positive remainder. And therein what we do is that we add this negative remainder into 11 to get the desired positive remainder. So 6 will be the remainder in a case wherein the odd place digit sum is 15 and even place digit is 20. So this is how the divisibility rule of 11 works. Let me also give you the logic that why it works. So let me take. So I'm taking a very small numbers just for our understanding, that let the number be a 4-digit number ABCD. So I can always write ABCD as 1000A plus 100B plus 10C plus D. Now again 1000A can be written as 1001A minus of A, plus 100B can be written as 99B plus B. 10C can be written as 11C minus C plus of D. So I have deliberately, what I have done is that I have taken those numbers which are multiple of 11. So 101 is a multiple of 11. 99 is also multiple of 11. 11 itself is a multiple of 11. So if I discard these three terms, these are the multiple of 11, so they will be divisible by 11 irrespective what the value of A, B or C is. But the rest of the terms which are left is minus A plus B minus C plus D. If I rearrange them appropriately, it is b plus or d plus b minus of c plus a. So if you look at closely, then d plus b is the odd place sum of the odd place digit, and a plus c is the sum of the even place digit. So this particular thing should also be divisible by 11 for the entire number to be divisible by 11. So that is the logic. Although it is not the most appropriate proof, but this is just an illustration that how this rules work. Now let's move to the next divisibility rule, and that is divisibility rule of 12. Now since 12 is a composite number, so what we do is we can write 12 as a product of two numbers of which the divisibility rule is known, but the only thing which we have to keep in mind is that, so whenever we break such numbers into two factors, we have to remember that these two factors should be co-prime to each other. They have to be co-prime. For example, 12 could have been written as 6 into 2 also. So I would have used divisibility rule of 6 and divisibility rule of 2, but this is not how it is done. We have to break 12 into such way so that the two numbers or the factors should be co-prime to each other. Co-prime means the HCF of the factors, for example 4 and 3 are the factors here, should be 1, or there should be nothing common other than 1 between the factors. So this is how every time we have to do. For example, suppose we come across a question which it says that we have to check the number to be divisible by 88 or not. In such case, what we have to do is that we have to divide 88 into 8 into 11, so that 8 and 11, the HCF of 8 and 11 is 1, or they are co-prime. In the coming section, when we'll take the examples, I'll also make it very much clear. So let's come back to the divisibility rule of 12. So we have to break it into two factors such that they are co-prime, and they are and we should also know the divisibility rule of those factors. So similar to 6, what we did, we have to use the same logic here, that if the number is divisible by both 4 and 3, then we can say that the number is divisible by 12. So for divisibility rule of 4, we know that the last two digits is checked, and for the divisibility rule of 3, we have to get the sum of the digit to be divisible by 3. So let's take an example that if this, to check whether this number is divisible by 12 or not. So the last two digits is 64, and 64 is a multiple of 4, so we can say that it is divisible by 4. But what about 3? For that we have to find the sum of digits. So here the sum of digits would be 5 plus 4 plus 0 plus 9 plus 7 plus 6 plus 4. So if you get the sum, it will be 9 plus 9, 18, plus 7 is 25 and 35. Now since 35 is not divisible by 3, hence this entire number is not divisible by 12, although it is divisible by 4. So it is divisible by 4 but not by 3, but to be divisible by 12, it has to be divisible by both. So this number is not divisible by 12. In the next video, we'll see the divisibility rule of numbers of the form 10 to the power n plus minus 1, and apart from that, we will also see the divisibility rule of 7 and 13 also.